Hell yeah. All right. Welcome to Hyperstition number 11, energy-based currency. There's some ideas that kind of come up again and again in history, and energy-based currency is one of them. Energy-based currency, Thomas Edison wrote about this. I think Henry Ford, Elon Musk's grandfather, I think Freeman Dyson talked about energy-based currency. And one night I was sitting down to write some kind of essay I had in my head for like a week or something. And then instead I just wrote something about energy-based currency instead, just out of nowhere, it just popped in my head. And I was like, this makes sense. And I think my approach to this concept and topic is really thinking about like, what is capitalism? What is industrial civilization? In my framing, capitalism, it's this evolutionary search algorithm to explore the space of possible economic activities or economic modalities, but it is constrained by these thermodynamic principles that we need to acquire and use energy. And that's underpins all of living systems, is this acquisition of free energy, of Gibbs free energy, this dissipation of Gibbs free energy. And this concept is also like in learning and intelligence, it is this active inference. It's the minimization of Gibbs free energy or the minimization of cross entropy or something like that. And I think there's this if human civilization is this kind of intelligent super entity that is trying to figure itself out, it is doing this thing. It is doing this thing of like finding energy and using it. But then now you look at like how we've actually constructed price signals in the economy using fiat currency, and that's not tied to energy at all, right? And so I approach this energy-based currency in the context of like, how could we naturally align price signals within the economy to optimize for the most important factor of production, which is energy. And so it's sort of this harmonious alignment. Anyway, it turned out people are working on this exact thing, and that's you guys. I'm really happy to have you guys here, Dr. Quai and Steph, today, because you guys are working on energy-based currency, and it's this whole network, it's this whole protocol you developed that I think has a bunch of cool math in it. So welcome. Let's talk about energy-based currency. I'll let you guys introduce yourselves, kind of what your background, what you're working on, kind of where your thoughts are these days.
Should I go first, Steph?
You're the man. You go first.
Sweet. So, name's Dr. Quai. Kind of been working in the blockchain space now for about 8 years full time. And a large portion of that time was kind of figuring out how we can move past what I consider like MVPs, like Bitcoin, and really get a functional, scaled system that does actually directly tie the token or the numeraire in the system back to energy, so that it can function well, not just as a store of value, but also as a unit of account. And really the bigger goal is not just being energy-based money, but energy-based money is really the answer to how do you separate money from the state? How do you make a trustless financial system? And how can it work at scale? And it seems that the only thing that we can trust in this world is math and physics. So a key part of that solution then is leveraging that to make that trustless system.
Yeah. I like that. Like government overspending and the centralization of currency leading to inflation, like the destruction of wealth, I think is very real. Whereas really, if you wanted to increase the money supply, increase the amount of energy that you guys produce as a society or something like, we'll get into that in a second, because I think there's a lot of nuance there. But, and Steph, you are at the Wolfram Institute based on your background, which is the Wolfram logo.
I work at Wolfram Research, and actually, that's the Wolfram Institute is a nonprofit organization related to Wolfram Research and the activities and workings of Stephen Wolfram, the physicist and computer scientist and computation pioneer, complexity scientist. So yeah, I'm in our blockchain group. I've been here for 5 years, and I actually met Carl a couple of years ago at a conference in New York City, and Carl was presenting on hashonomics, or the economics of hash rate. And 15 people were there listening, and we had a conversation afterwards. And I'll admit, Carl was definitely thinking about things in a deeper, more structural way than I had been for a long time. But I had been paying attention since 2015 with Bitcoin because I was deeply curious about the relationship between energy, computation, and value. And value to me was always the fun thing to play with because it felt so subjective. Yet there was also this whole monetary system that, in another kind of end of the spectrum, was objective. It felt, or there was something else being measured. And I was always very curious about that. So in 2021, I pitched Stephen Wolfram letting me join Wolfram Research to study this intersection of those three major things. And Bitcoin was the kind of key focus, proof of work, because there's something that Edwin James pointed out in 1957, where there's this mathematical relationship between the conversion of free energy into entropy and how you could lift the formalism off of that. And that seems to like appear in so many different domains.
Yeah.
And
Yeah.
yeah. Sorry. So long story short, the past year and a half, I've been kind of exclusively focused on Quai network because I think we're seeing how you can hit that fundamental kind of limit on what proof of work can do. And Carl and team at Quai network have this incredible take on it.
Mm-hmm, mm-hmm. Let's kind of hover at the in this kind of like the nature of entropy and energy and compute, and then kind of get into, I think, how you guys are executing on that with your particular implementation and protocols and stuff like that. I'm curious what you guys think about this. I mean, people have said in the past that like Bitcoin is like energy money, basically, or that's often like a phrasing that I think has been applied. But I think like this concept of like, to exist as living creatures, we need to be acquiring energy. We need to be externalizing entropy, removing entropy from our environment. This is like Carl Friston's work on active inference, is like this minimization of local entropy. Or am I framing that wrong? I mean, do you guys see the connections between, in my mind, it's like this connections between like price signals and value in an economy sense, and then also just like this kind of thermodynamic constraints on like living systems and organisms in general.
Yeah, no, we think deeply in the same way. We think there's a lot of parallels here. Let me address the Bitcoin point, and I'll let Steph address maybe the other analogies. Specifically with Bitcoin, when they refer to it as energy money, what you're effectively trying to do is you're trying to create a token that represents, a certain amount of energy, right? If you look at sort of a very first order concept of an energy-based economy, you might come to the idea that you need to trade kilowatt hours directly in sort of kilowatt hour form. The problem with that is that there simply isn't enough kilowatt hours in existence instantaneously to run the economy. And kilowatt hours then in true form have both a physical representation and a temporal and a locational representation, right? So a kilowatt hour in California isn't the same as a kilowatt hour in West Texas. Getting it from one place to the other isn't free, et cetera, et cetera. So when we think about energy-based money, if we just think about trading kilowatt hours, there's not enough of them, and they're not easily, inexpensively stored, and they have these properties that make them not really fungible, right? So once we get one level up from that, we can say, okay, is there a mechanism by which we can fairly and accurately represent energy or previously expended energy as a token, as a numeraire, so to speak, and then can we use that as the representation in the economy, right? And Bitcoin kind of figured out how to do this a little bit with proof of work. right? So when you look at Bitcoin, people have to mine blocks to mint Bitcoin, and the price of the market price of Bitcoin tends to want to converge to the production cost, which is largely dominated by their energy input over time. Now, they're not instantaneously linked, but they do tend to converge over time. Now, that would make then Bitcoin kind of appear to be energy money like. However, there's one other piece to Bitcoin, which is the monetary policy, which are these halvenings, right? So initially you got 50 Bitcoin per block, and then every 4 years it halves. Right now you're getting 3 1/8 Bitcoin per block. Or 3 1/4, I think it is. So the point, though, is because of that sort of deflationary monetary policy, if we look at the total market cap of Bitcoin, it actually far exceeds in representation the amount of energy that has gone into Bitcoin in aggregate, right? So although instantaneously the process of mining gets us this connection between energy and the token value, because of that sort of artificial and arbitrary monetary policy that creates that deflationary curve, the market price strays away from the production cost over time. So then Bitcoin doesn't sort of represent energy money anymore over the longer time frame because of that deflationary curve. If that makes sense.
Yeah, and it kind of makes me think, I mean, like, if we call Bitcoin this energy-based currency just because its primary factor or its primary cost of production is the price of energy, I mean, aluminum is like an energy-based currency because half the price of aluminum is the embodied energy, and like energy is like, it's the most important commodity input into every productive process on the planet. Any kind of metal refining process or extraction is extremely energy intensive, so it's kind of, I mean, I think this is the thing. Maybe we can get into this in a minute, but it's kind of like we want energy to be as cheap as possible, always getting cheaper in time, and that's this plot that I think I've farmed for so much engagement on Twitter, which is just this plot of like countries. There's no energy poor rich country. That all wealth is downstream of energy, and like actually, like historically looking back, like Industrial Revolution, that led to an explosion of population and a decrease in poverty and decrease in starvation because there's so much more energy available, right? And so I guess this is why I think this idea is so interesting and powerful, because I think if it's done right, we kind of have this like interlock between like what we're trying to do as a civilization and survive, and how we incentivize economic actors to go out and do stuff in the world where they have to be, for a business venture to be profitable, it is like adding to the net increase in energy in some way. So I don't know what you think about this stuff, like in this kind of like this kind of econophysics, or this almost like philosophy of economy perspective. Like, do you see the economy as like an energy heat engine, or is this like too simplistic?
I do. Econophysics, there's thermoeconomics, there's kind of a term that's thrown around. I'll start with the place that I think you led well to, which is you're pointing out thermodynamic constraints. I think constraints are the right way to just get a grasp on what is possible and what is not possible, and then evolve a system through those fields of constraints or opportunity sets, and you get to what Carl's talking about, Dr. K is talking about at this cultural level. But I want to go back a little bit and say one of your previous presenters, Sam Senchal, was talking about observer theory and the Ruliad, which is a kind of formal mathematical object that Stephen Wolfram has named and has kind of defined it as the space of all possible computations. And in that space, there's really no constraint. It's just everything is possible. What that gives you, though, is kind of the place to begin to know that what's possible is this multi-way hypergraph where you could take any infinite number of sequences and potentially merge at a future at a future point. The reason why I'm bringing that up is because up at this economics level, where human imagination, compute, and energy resources kind of start to unlock this enormous future, it's possible. It's of the possible state space. But we need to know what is actually constraining our options or our sequence of events on that state space. And we can get to a future from many different possible sequences, but not all of them. Some of them are cul-de-sac. Some of them are an evolutionary dead end. Some of them burn out before we actually get there. And so what we want to do is open that space of possibility, but then understand really what are the true constraints that we're operating with, and use that as our frame of reference to navigate an extremely complex system. And so it really, we need fundamental things that help us kind of see the state space. And that thermodynamic operator or that energy tie is something closer to reality than potentially a non-algorithmic rule on the production of money or on the symbolic nature of language, where one culture can't speak to the next, can't speak to the next, but a meta language may arise to help us coordinate.
I think that's really interesting how you frame that, because it's like we are like physically constrained in many ways, but what you first started off with on this concept of value, like I'm kind of the Vienna school of value. I don't think it's embodied labor. I don't think it's embodied capital. It's subjectively assigned, right? Like what we value is subjectively defined, and this is this like kind of bid price on market goods or commodities or whatever. It's worth what you think it's worth. And so economics is where the psychology of the crowd meets the physics of reality, right? And so it's kind of like we can't like talk ourselves into these cul-de-sacs. Like I think a good example of like a sort of an energetic dead end is biofuels, right? I can knock on biofuels. None of my friends work on biofuels, but it's this idea of like growing crops to extract energy from them. And then if you look at like what like probably the best metric for understanding like energy production is return on energy. You know, I take like a barrel of oil equivalent and I get 10 barrels out. And in early days of like oil and gas exploration, like this is kind of 1800s-ish, but you'd get like 100 barrels out, right? And that's gone down over time to now like tar sands and fracking. It's like, I don't know, 4 barrels out, 5 barrels out, whatever. But to have industrial civilization, we need to have a return on energy value that's, I think, like at least 7, basically, like a 1-to-7 ratio. And then below, you can think in the limit, if it's just 1, all of society is trying to harvest and extract energy. Like everybody's just trying to get that. So it's like, if we voted ourselves, and this is, I think, the issue with fiat currency and subsidies and the distortion of true price signals, because we have this complicated situation where prices are both like, you know, we have not really rational actors, right? We have like basically semi-irrational actors that are influenced by sentiment to do things like, let's massively subsidize a bunch of like wind farm plants. Like Samsung did this in the North Sea, and I think it's become like, it's a money losing operation. Like wind turbines are actually like really bad. Like the blades don't last very long, tons of embodied energy. There's not a lot of output. And so this is why I think like if we denominated our activities in some kind of unit of account that represents energy production or embodied energy, and you have to run a profitable business to survive, there's actually no way of getting down this blind alley. There's no way of like, you know, the story of like the tropical island where they chop down the last tree to make a canoe or something. Like there's no way of getting into this civilizational dead end if you've actually kind of implemented this the right way. So that's why I'm super keen on this idea. For the record, I don't have any Quai tokens or coins, and maybe I should. I probably should, but I haven't. So I'm not just like talking my bags here. Okay, so I'm curious then. Bitcoin is not really this embodiment of energy. It's sort of a proxy measure, but we want to have currency tied to energy so that it is like aligned with these incentives of the industrial economy. How do you guys actually approach this? Like, how do you actually like kind of get to where we want to be, where we can have like avoiding these like dead ends, I guess, like in a kind of engineering perspective?
Yeah, great question. You brought up biofuels. It's a slight aside, but I just have to speak to it because it's so apropos here. I believe that biofuels are done as a geostrategic industry that links the price of oil to food. Because if you look at the United States, we have massive amounts of food production, but we historically didn't have massive amounts of oil production. And so what ended up happening with biofuels, we were dependent on sort of the Middle East to sell us oil. Now, if we basically said, we're not going to give you food if you don't give us oil, that is like one sort of outcome. Or if we just make it so that those prices are locked together through the biofuels industry, it means that it puts a ceiling on what Saudi Arabia can charge for a barrel of oil, because if they charge too much, they won't be able to afford the food. So it's actually like a thing that causes a correlation in the pricing of oil and food. So, you know, I don't know if that's why it was done, but that certainly was the outcome of it. Anyway, so yeah, sorry, slide aside. But when we're talking about energy-based money, right? The original one, as you kind of mentioned, was metals, right? If we look in history, and it's not just gold, it's just gold happens to be one of the best metals because it doesn't sort of degrade. Metals was actually the first mechanism by which you could sort of keep wealth with time. You know, prior to that, maybe you had, you know, pots or blankets or, you know, food or housing, which had a relatively quick depreciation curve just from wear or spoilage over time. So the advent of metals as humans was really the first mechanism by which we could store value or accumulate wealth over a long term in an intergenerational sense of it, right? And I think, you know, gold obviously is you know, the penultimate manifestation of that. And really why gold is valuable is because it does a good job of reflecting the energy. The market price tends to follow the production price. And then you obviously have, you know, these items of it's durable, you know, tradable, fungible, verifiable, all these things. Now, some things are harder than others.
It doesn't rust. Like silver, gold, platinum don't rust. Like other metals over time might oxidize. And
well, silver does tarnish, but platinum and gold don't, right? And so like it makes for a good money. But the key characteristic when you talk about sound money, my definition of sound money is that the mint cost equals the sort of market rate, and when that and it's has a high degree of counterfeit resistance. Those are like the two characteristics of sound money. So that means if we look at like a dollar is not sound money because, you know, $100 bill costs a penny to produce, right? So its production cost is very far away from its face or its market value. Now it has a good degree of being resistant to being counterfeited. But those are kind of the sort of the two characteristics that I think define you know, sound money. So that's like sort of the basis by which you can then make the leap of saying, okay, how about I have a system that doesn't have to have the physicality and some of the disadvantages that come with that physicality, like gold, but carries forth, you know, the property of soundness, meaning its cost of production sort of matches its face value or its market value, and maybe even improve some properties like verifiability, as well as transferability, et cetera. So with Bitcoin, right, we have this link of hashing, this proof of work concept that basically allows math to sort of get a you know, a foothold in the thermodynamics of the world. And we can leverage that to then make that link between thermodynamics and energy and the tokens themselves. And then we can actually, improve upon some of the characteristics, right? So, one issue with gold is like, why don't we still run on a gold economy if sound money is so great? The reason is that it's hard to divide, it's hard to store, it's hard to transport, right? And the difficulty around those three physical properties of gold is actually what created the opening for gold-based notes. And then gold-based notes created the opening for fractional reserve banking. And then fractional reserve banking created the opening eventually for fiat. So we need to actually address the shortcomings of gold, of transportability, divisibility, verifiability, with a new system that's digital, but then preserve the good characteristics, which are the soundness and the ability to not be able to counterfeit it. And then we can create a money system that hopefully then won't be replaced by notes, out of this, convenience around the properties of use. Right. So I know I kind of went down a winding road there, but
let me ask you about some of these ideas, because I'm really curious to understand. First off, I'm curious why we actually want like the face value of a currency to equal its mint cost of production. What's the intuition or rationale there? Because very simplistically thinking, like, we have like 200 units of value of the economy, and we want to have 200 units of currency to represent that value. But now to produce that currency, I have to destroy all the value or something like that. Like there's some kind of, why do we want this face value to equal its minting cost?
Because that's when you have that property, that's when it can't be easily manipulated. Right. So that's the property. We think of that as sound money. But really what you're doing is you're trying to make the information about that unit most accurately reflect the reality of the energy and the physics behind it.
And there's something like, I don't know, this is Karl Marx talked about this, something, but like this different, or maybe it was him and others, but like the difference between like use value and exchange value, paper currency has no use value apart from like lighting it on fire and staying warm or something like that. Is this kind of related? Like, do we want, like, is the ideal currency something that actually has like it could be used in some productive process? Like, and I guess this is like, no, okay, we don't want that. So it always stays currency, or it always stays.
Yeah, I mean that's why gold kind of takes the place as sort of a currency, because it has no use. I mean, people say, okay, you can make jewelry, this, that, or the other, but 97% of gold is just a monetary asset.
Right,
like,
right.
We don't consume nearly as much as we produce. We just hold it in vaults and we trade it as a unit or a store value. Like that's all it's used for. Now, if we look at silver, on the other hand, the yearly production of silver is fully consumed. And so when AI starts taking off, or solar starts taking off, suddenly the demand for the industrial consumption vastly changes the pricing of what's supposed to be the money. So then that makes it a bad money system if silver's tripled over the last 12 months. Right. So if sort of the value of money tripled, that wouldn't necessarily be a good thing for the economy. And conversely, it's probably going to make a 50% retrace, before it continues on up. But that volatility also doesn't make for good money. So money itself should be something that ideally is independent from other demands and other productive processes. So you want something that is the ideal form of money, can only be used as money and nothing else.
And I think you just described why Bitcoin is like a terrible currency, because its value is extremely variable and tending to go up. Like, people are very disincentivized from spending Bitcoin if the value just keeps going up. It has not become a currency. It's become like an asset. It's become like a buy and hold thing or something.
Yeah. So, I mean, that talks about Gresham's law, right? Which is basically, the superior form of money will be hoarded, the inferior money will circulate. So when we go back to, gold and gold notes, everyone knew that gold itself was technically superior because it didn't have counterparty, storage or redemption risk. Now the notes were technically more convenient, right? And then when they became fractionally reserved, people knew that there was material counterparty risk. But if there's material counterparty risk and I have an ounce of gold or a 1 ounce gold note, I'm going to give you the 1 ounce gold note, and I'm just going to hold on to all the gold I have because I don't have any counterparty risk on it. So I'm going to end up hoarding that valued asset rather than circulate it in the economy. And Bitcoin then suffers from its own success in some way, because as the value of Bitcoin goes up, certainly relative to the dollar, people are less and less likely to circulate it. But then the catch-22 for Bitcoin is, over time, the design of the economics that Satoshi intended was to have transaction fees replace the inflationary fees. That's why the inflation goes to zero. But without the scale, only doing 5 transactions per second, there's no way that Bitcoin can generate enough revenue to offset the loss of inflationary subsidy and still have a great enough incentive for the miners to secure the blockchain, right? So in a proof of work only system with only one token that wants to be hoarded, you actually end up in a very unsustainable system where, Bitcoin will never be able to sustainably pay for its own security. And if I can't pay for its security, I can't continue to function as money, because people will be able to double spend it. So there's actually this conundrum with just having a store of value in a system that makes it so, at least in all thought experiments that I've run, impossible to have actually a sustainable economic system.
I'm sure some people would say there's I don't know. I'm no blockchain expert. There's layer 2 or layer 3 technologies that can somehow get around this transaction rate limit type thing. But this really isn't. I don't actually care about Bitcoin at all. I care about energy-based currency. This to me is a philosophically appealing concept, and I am curious, okay, so you have a few ideas out here. Sound money, the mint value should be equal to its face value, and it can't be counterfeited. Those are the 2 properties I think you mentioned. And we have this desire to have this unit of account be represented in some way of energy that's been. Is it now? I think this is where we get into the weeds here. Is it energy that's been produced and is stored somewhere, like gold would be in a Fort Knox, or is it energy that's been produced and consumed in some kind of process? And I think that's kind of a simple question, but the real issue I would see is we want our currency to have a constant real purchasing power in time. We actually don't want inflation. We don't want to inflate away wealth. I don't know how we got this idea. We want 2% inflation every year, so people are always getting poorer. I think that's dumb.
It's propaganda from the central banks to justify their existence. Is where
the more I've learned about fractional reserve banking and the central banks, the more I'm like, this is such fraud. This is they're producing no value and they're just printing money into their own pocket. It's anyway, whatever. I don't want to get assassinated, but the point is that we want a real constant real purchasing power in time for our currency, right? We want $1 to be worth $1 tomorrow. We don't want that to inflate away. We don't want that to deflate away. Those are bad outcomes. But we also want energy to get cheaper in time. So how do we kind of square the circle there on we want energy to be cheaper, we want our face value to equal the minting cost? Is there a contradiction there for an energy-based currency?
No, I don't think there is, because what ends up happening is you want your purchasing power to be the same. So if the cost of energy goes down, the cost of goods will go down. But the amount you'll be able to buy with a fixed amount of energy is consistent. If that makes sense. So
yeah, that's a very simple answer. That was simpler than I was expecting. Right. Actually, energy growth has been pretty much 2% per year, growing, compounding annually.
Well, and if that happens too, you will actually have a economy that's a little bit smarter, because you'll potentially eliminate the bullwhip effect in supply chains based off differences in pricing. Sort of everything will instantaneously reprice based off the change in energy prices.
Interesting. Okay.
So right, let's say I have this spindrift here, right? And it was $1, but then aluminum, or let's use an energy money unit. If it was $1 and aluminum's price doubled, maybe I have to pay $1.50 for it. But if it's one energy token worth, and the price of aluminum doubles because the cost of energy went up, I should still be able to exchange one energy token for one spindrift.
Mm-hmm. Mm-hmm.
That makes sense.
Yeah, I like this direction just as a playground, and I've been really interested in getting like better and better large scale frameworks for people, myself specifically, to play in the playground of what is the energy landscape of our modern life, and to see the world, see nature in kind of its natural flows. And I mean, you can, when you do look at nature, you can see the energy flows at all times if you're looking for it. And what Carl talks about, at least in acknowledging that there's a new way to see something, which is not very easy for us to just immediately embody and start to bring into the kind of conversation, because this is where you get things like let's stop thinking in dollars and let's start thinking in energy units. But up at our cultural level, we're thinking of energy units that have come from a abstract set of work. Like, you know, I sit down in front of a computer and I am pushing bits around that are work that pays something in a dollar unit. I'm not trying to overcomplicate this, but I'm trying to say that there's something really beautiful about trying to think about the world in an energy landscape first, which is what I do think people like, you know, Elon Musk does when he acknowledges that the sun is 99.98% of kind of all the flow in our solar system. And when you think about that, it becomes really obvious that that is the main driver of what things cost in our economy. And then if you just take that point of view and start to really, I don't know, diffuse it into any action, it gets clearer. But it's not easy to talk about with other people because we just don't have the language for saying it yet.
Mm-hmm. Mm-hmm. Yeah, there's when you mentioned this thing about moving bits around in a computer, there's kind of this natural exchange rate between information and entropy, and therefore also energy, right? This is Shannon's theorem, right? So it's like an amount of energy gives you a certain amount of entropy, and that's convertible to energy at a temperature, right? So it's kind of like, and I think about this in terms of like, there's like three products in the universe, you know, there's energy, there's intelligence, and there's like dexterity. It's like moving atoms around, right? You know what I mean? That's it. And so intelligence, I mean, these are also the only three like factors of production, basically, for any kind of good or service or whatever. And I think now, you know, the metric that we're all optimizing for in the AI game is kind of flops per watt, right? It's how much intelligence can we get per amount of energy? And now there's no real lower bound on that, actually. There's not like, there's you know, our human brain runs on, no, there's not, because actually, if you think like physical processes, you know, the Schrodinger wave function evolves unitarily. It's lossless. So information is conserved in time. And so there's no lower bound energy cost for some kind of information bitwise operation if the process is fully reversible, if it's adiabatic. You can beat Landauer's limit. That's the whole point. I had earlier last week a guest on talking about adiabatic reversible computing by using inductive. So most of the parasitics in circuits are capacitance, right? And so by having inductors that match the frequency of operation, you can have energy bouncing between different kinds of storage elements to have a computer that's operating in a lossless fashion. So there's no lower bound energy cost on intelligence, but there is always a lower bound energy cost on moving atoms around, because a Newton meter is always equal to 1 joule. And so think about like, you know, right now energy is like half the cost of aluminum, and the other part are more, you know, depreciation of capital infrastructure and that kind of stuff. But in the kind of limit of like perfect capital goods or perfectly durable capital goods, things that last essentially forever, like a nuclear reactor is like getting close where it lasts like 100 years and it keeps outputting the same amount of power, then energy is really the only cost of production of anything. And so this thing about like you want constant real purchasing power for your energy-based currency, well, it's not everything has energy as its only cost, but in the future, energy really is the only cost of doing anything. Energy is the only cost of intelligence, and we can get way more energy productive leverage on the production of energy, on the production of intelligence, right? A kind of productive ratio. Dexterity is something else. So I think like this is now kind of gone a little bit off, but I guess I'm making the point that it's like Eric Schmidt had this quote. I love hating on this guy. I don't know why. I think he's probably very smart about points and stuff, but he was like, oh, in 10, 20 years, 99% of all our energy will be spent on computing. I was like, no. I mean, in 1910, people were like, in 10 years, the streets of Manhattan will be 6 feet deep in horse manure. We invented cars. We'll invent reversible computing. I don't think intelligence, like because there's no lower bound on the energy cost of computation. Well, there maybe is, but it's extremely low. But there is on this dexterity element. I think this is like basically in the future, it will make sense to measure the cost of everything in terms of energy. And now I've gone on a long rant, and I'm supposed to be here interviewing you guys. Okay, so I don't know if you want to respond to what I said, or we can get back to this Quai network.
Well, I'll just say, I mean, as an engineer or physicist, saying you can actually get to truly adiabatic conditions, right? That's always a simplifying assumption. You might be able to get close, but you're not going to ever fully get there. So, but I would agree that the limit for intelligence, the sort of evolution of AI over the next 5 years is all going to be about energy and just how to simplify and make more efficient compute relative to the task at hand. So, I think, more neuromorphic computing, may make a comeback here because really it's just driving down towards that limit. So I do think there's a long, long way to go that we can exploit. But actually achieving adiabatic conditions never seems to happen in reality, right? So
it's a good point. I guess I was trying to say like the lower bit, like we can probably get more energy leverage on intelligence than like, shaping metal or something like that.
Yeah, no, I think that's fair, right? Because one's a relatively new process, one is a relatively old process. So, metal and moving the atoms around, we've been optimizing for a few hundred years now, right? Whereas AI stuff, it was actually pretty funny with DeepSeek R1. If you actually read that paper, it's interesting to see like how far removed the AI engineers are from the actual like code that runs, because basically all they did is they realized that they're multiplying two arrays together, and with each progressive step of the LLM, they're adding a new row and column, so they don't have to recompute the existing matrix in every step. But that was very much just like, if you looked at how it operated and you looked at the math, that would be your first order sort of optimization. But it took R1 to do it. And, they had already been spending billions of dollars on inference for multiple years before somebody figured this out and got like a 10x improvement efficiency. So, the point being, we're very naive and we're very unmature in terms of how we actually do the compute in terms of its power consumption.
Mm-hmm. Mm-hmm.
Yeah.
I wanted to add something too. That's I'm not an engineer or a physicist, and I don't really want to claim that I'm an economist, because up until this point, I don't think I've really had the right tools and framework for being a great economist until the proof of work era, in my opinion, and really precisely in the proof of entropy minima era of currency production. But like, I don't want to disagree that the possibilities of our technology are limited. So like reversible computing or whatever we're talking about here, I do think is available to us in the possible set of future states. But what I'm concerned about is that we acknowledge that that can happen, and then we specifically optimize for one path, the direct route to get there, and we forget that evolution does more of this trial and error, explore, exploit space, state space. And if we too narrow-minded tunnel, I don't know, that's the end of the day. We're too narrow focused on getting to that one specific end, then we forget to acknowledge that we are still finite, bounded computationally, yet that's changing. And what reference units we use to make our decisions in that opportunity landscape needs to be as low error as possible. And in our current regime, the reference rate that we use across 8 billion people on an enormous economic highway has some non-zero error rate baked into every single thing we do. And if if in aggregate, we have quite a large error in the signal that is our economy. And so it could really incentivize the thing that you're saying, Andrew, that's right and accurate, but in too kind of purely that path, or too strongly accelerated in that path, and we don't give ourselves the options of getting there, but in kind of multiple ways, or like with more resilience rather than optimization. So I don't know where would you land on thinking in kind of resilience rather than optimization?
Yeah, it's a good point. And I mean, I think that's I think this evolutionary mental model gives a lot of conceptual leverage on understanding like this creative destruction process that Joseph Schumpeter wrote about, which is like this periodic upsetting of existing modes of production, or not modes, but business models, methods of producing things, types of business, types of consumer markets, that kind of stuff, where it's really, and I think this is another thing to think about, is that evolution does not optimize for individual outcomes. It optimizes for population level outcomes, which means that you have some amount of the population that has what look like deleterious genetic adaptations to things. Now, those may be deleterious in normal operating conditions, but when everything suddenly changes, they may actually prove to be resilient. So having this like reservoir of variance in terms of how you approach things, such that we have not hyper optimized for this one narrow thing. This is my own thing too. It's like, I don't think AI is the end of technology. I don't think robotics is the end of, I don't think in 100 years we're going to have like Newtonian propulsion spaceships. I think there's a lot more going on probably. But anyway, so it's kind of like it is this periodic erosion of supreme returns commanded by one business model. So it's the process, and this is Carlotta Perez writes about this, but it's like this. You have this initial new technology that commands massive premiums in terms of high returns, but new entrants copy that. They compete away those returns to make it a commodity. And from that place, everyone now tries, you kind of have this periodic equilibrium, right? It's like the Cambrian explosion, so it's like when the dinosaurs died out, you had a new flourishing of all these different kind of, that's not that's a different extinction event, but you know what I'm saying? It's like, so it's like this AI revolution of technology is the fastest to commodity returns in history, right? And it's the fastest adoption cycle. But the commoditization of those returns means that the tunnel vision focus on this particular type of economic activity goes away, and people now have to spread out. You have this vanishing gradient. You actually want a periodically vanishing gradient so people start to explore a high variance path of outcomes. And that's kind of, I don't know, this is weird evolutionary biology philosophy of industrial capitalism. But I want to get
Yeah, well, I like that. Maybe I can prompt Dr. K on the next question, because you said a reservoir of variance, and I'm looking at this object on screen which has it has a gradient baked into it, and it has this variance, which I would like Dr. K to talk about, which is kind of how to think about proof of entropy minima, because there is this structural algorithmic arbitrage available in proof of work consensus that I think Quai is hitting kind of a limit on, and it makes available a new landscape of possibility in proof of work. And I don't know if Dr. K, if it could prompt you into just talking about maybe variance and I don't know how to ask the question.
Yeah, no, I can kind of segue here. So maybe the place to start is actually sort of why we're collaborating with Wolfram, right? Why is Stephen Wolfram an advisor of our project? So initially with Quai, we kind of took this approach that was very much an engineering based approach, which is, how do you scale a blockchain so that you have greater throughput, right? And with greater throughput, you can potentially create sustainable crypto economic systems where you can generate enough revenues from transactions to pay for security over time without having a persistent inflationary subsidy. So, that started, very simply, which is saying, let's, use, typical CS type techniques or networking techniques and create shards and subnets. But, how do you do that in a consensus-based system? So sort of the initial idea is, okay, we're going to create this hierarchy of merge-mined blockchains, which is going to allow us to have a single consensus mechanism that resolves the ordering of the shards and the subnets. And one description of that system could be a multi-way graph. Another description is a DAG. But what ended up happening is we built this system that could do this sharded topology of hierarchically merged mined blockchains, and would allow us to scale to very, very high throughputs, so that you could get Visa, MasterCard like performance out of a decentralized blockchain based system. Now, one thing that we ran into though is that the mechanism by which we were coming to consensus was not causally invariant. So we were using kind of a variation on proof of work that we called the hierarchical longest chain rule, to try to pick which one of these, green chains is sort of the leader in the system at any given point in time. So sort of how do you resolve who's winning effectively to pick what you think your canonical state is and how to extend it further. And that ultimately led us into sort of an unsolvable loop. And what we ended up coming up with was a variation on proof of work called proof of entropy minima. And what importantly that did to the system is it made it what we would call a causally invariant. So basically, we can kind of work through like a simple example here, but if I'm mining Bitcoin, right? There's when a Bitcoin block is found somewhere in the world, it's broadcast through the network. But as it's propagating through space, someone else could sort of mine a competitive Bitcoin block. Now there's two Bitcoin blocks in the network, and the network doesn't know which block to choose. Is it A or is it B? And there's no good way of resolving if it should be A or B using typical proof of work choice rules. So you have to actually wait for the next block to be found on A or B, call it block C, before we know which path we're going to take. So there's this point in time where just based off where the block was produced and when you saw it versus when, say, Steph saw it, you guys are going to be in disagreement about what the state of the system is. So just based off the order in which you saw the blocks, they arrived at at your location. So, Andrew's going to think it's A, Steph's going to think it's B, and until we see C, there's no resolution here of what the state of the system is. So with proof of entropy minima, it basically makes a deterministic choice rule that doesn't spoil the game theoretic cooperation of proof of work. It's actually better in many ways. But it's done such that each block's weight has sort of a guaranteed uniqueness or goodness to the point of a hash collision. And hash collisions basically will never happen. So there will never be two blocks in the system that are equally good, right? And that's where the causal invariance comes in. So if we did the same, simulation in our head where two blocks are just naturally produced because of delays in propagation, Andrew sees A first, Steph sees B first. Now let's say B has a higher entropy reduction than A. When Andrew sees B, he's going to immediately switch to B. So the second that we all have the same information, we're all making the same choice, which creates this property of causal invariance. And now we have something that's a causally invariant multi-way graph, which is the closest analogy I've ever seen amongst seemingly different systems, but it's very, very close analogy to Stephen Wolfram's, theory of physics. So that's kind of why we started collaborating, because they seem to be convergence, which is in terms of how do you model the world, you're actually asking in some ways, how do I resolve events in space? And if I look at blockchain, I'm actually asking almost exactly the same question, which is how do I order events in space, independent of time? And that's really what Poem gets us.
Yeah, and Andrew, I think I would just say entropy is the arrow of time here in this system, and it's just like it's such a amazing, simple rule, and that's why I've become obsessed with Quai Network, because it's very simple, it's elegant, and it really, entropy is the leader in this blockchain. So I wanted to prompt that. I'll give it back to you.
Yeah. So there's a couple of sort of like consequences. One is you can actually say that you're never out of consensus, right, in the system, because once we start the blockchain and we have the same rule set, as long as we see the same information, we will always agree. So your only limit in terms of this system to get to the point where we all are saying the same thing is consistency, is just propagation of the information, which you can kind of think of as just, you can go to, your light codes and draw your intersecting boundaries, but we can resolve them causally is the point. And another thing that's kind of interesting in this system, you could think of the hierarchy as the sort of the top chain, prime being the leader. Prime is actually the follower, and every one of the zones is technically a leader. And as they're sort of progressing and making, their block choices, whoever has the lowest entropy is the aggregate system leader at any given point in time. So I can have an infinite number of leaders in the system, which is how we can do the sharding and the subnetting, and then causally resolve how they all work themselves through, because I know that they can never actually have the same value, right? So in the system, I always know that there's exactly one leader. I don't know who it is, but the system will resolve to who the leader is restricted only on the speed of the propagation of the data.
This is insanely cool. I just gotta pause in for a second, because we started with this, like, talking about, like, money and incentives and fiat currency. And then it turns out to actually implement this energy-based currency, you get into this, like, computational view of physics, this causally invariant multi-observer graph construction of things, where, like, physics, just a few things you said are just like, that's physical reality. It's like all observers should agree on the same observations, like, so long as they have mutual information, right? Like, we are causally connected, we exist in the same light cone, like, you see the ball's red, I should see the ball, whatever, this kind of stuff. I'm curious, okay, so this has, like, some badass mathematical foundations. In practice, I'm trying to think now, in practice, what is kind of going on? So we have this, okay, so we have this, like, mathematical framework to avoid this sort of production of orphan branches where we don't really know, like, what branch to follow. So we're going to follow this, like, minimum entropy branch always as the forking rule or decision rule. Now, pragmatically speaking, like, if we wanted to use this as a currency, like can it sustain the volume of economic activity, or do Quai coins that get mined, do they represent each of them like a jewel or something? Like, kind of what's the connection now back to this? Like, we need energy, and we need to like run our economy. And it's cool if our economy works in the same sort of, multi-graph causal invariant theories of reality.
Yeah, well, so it's very interesting. Everything seems to like converge at some level for some reason. I guess just because if you're trying to get to like a true basic description of reality, everything looks self-similar in some ways. So in this system, what we're doing is, from a very practical standpoint, you have to say, if we are going to replace the current money system, what are just the functional engineering requirements, right? And say 5-second sort of confirmations, throughput on the order of 50 to 100,000 transactions per second, fees that are somewhere around maybe a penny or less. Those are just sort of practical engineering requirements to create a system where a person would want to use it more than the existing one, right? So from that is like what gives rise to this structure and this hierarchy in Poem, which is we need to design this proof of work based system that can meet all of those requirements. So sub-penny fees, 50 to 100,000 transactions per second, 5-second or less confirmations, right? And so that is like where that design comes from. Now, in the system, in terms of the tokens, there's 2 different tokens. And we don't think that you can make a system with just one token. You kind of have to have 2. And the reason is you need a store value, you need a unit of account, and you need a medium of exchange. And there isn't a system, at least that I could dream up, where one token could serve all of those purposes. So in the system, we have Quai, which is a more sort of traditional deflationary token type system, like a Bitcoin. It's EVM compatible, it's programmable, it's account based. Now, in the same chain system, we have a separate state root that we have a second token on called Qi. Qi is the one that's linked to a certain number of hashes. So basically, you produce 10 e to the 18 hashes, like you get a Qi. And that basically links the value of Qi back to the production cost, which is predominantly energy derived. And then Qi also has this nice property, of cash-like privacy. So that's really meant to be the unit of account as well as the medium of exchange in the system, where Quai is the store of value. But we're using proof of work to not only scale the system. So if you kind of start to think about that property of causal invariance, I haven't constructed another way of creating causal invariance in a distributed setting that isn't proof of work. So even if we said, like, let's do proof of stake would actually devolve into mining if you were trying to get the causally invariant property. So basically, there's something about causal invariance and proof of work that are inextricably linked, it seems. But that also then gives us that nice little foothold into creating a token which is related to energy or the thermodynamics of the physical world, which then allows us to ideally create a unit of account or a money system that has a very low information loss in its use, right? Both in its production as well as its transmission. And that is really the goal, right? So in very roundabout ways, we were basically saying the money today sucks because it doesn't have high fidelity of representing real information. It's manipulated politically, it's manipulated by the banks, it's manipulated in many different ways so that it has its high loss in the system, both in terms of the information that it's really representing as well as the cost of it running through the system. And what we're trying to do here is we're trying to have a very high fidelity signal on what it represents relative to the real world and minimize the friction of it flowing in the system.
This is amazing. There's a lot going on here. So just to kind of reframe in my own understanding. So so miners on this network, they are producing both this Quai, which is this longer term deflationary kind of store of value, something more analogous to Bitcoin, but they're also producing Qi at the same time. And that is like this expendable cash that is maybe has more anonymity or something associated with it, where it's like paper money. It's like you can spend it. There's no traceability, I guess, necessarily.
No more than if you had cash.
Yeah. Okay. That's cool. Are you saying now ultimately tying this to energy comes through the mining cost and like the hash rate? Like that's really what ties us to energy. But now is that because we started off talking about Bitcoin and how it's sort of a proxy energy currency, but is there something about how the block size or the hash rate or something is keeps this more pegged such that the value of Quai or Qi or either one is more attached to the price of the energy it took to produce them?
Yeah, so that's a great question. So there's like 3 layers to the answer, but the very first one is that a Qi is issued just relative to a certain number of hashes, right? So we don't have sort of this artificial monetary policy. The monetary policy of Qi is to produce Qi in a way that it should always represent roughly the same amount of energy over time, right? Qi isn't meant to go up in value. It's not meant to go down in value. It's really just meant to be a proxy for energy. Like that is the monetary design of the system. The other thing, and this maybe harkens back to some arguments that Keynesians would make for central banking, which is although gold, has this property where the production cost wants to converge to the mint, it has a very inelastic supply. And so one of the arguments that they made was because of that inelasticity in supply, it creates booms and busts in the economy. So therefore, we need a central bank and we need a non-gold based asset so that we can adjust elasticity. The cool part about this system is the supply of Qi is much more elastic than something like gold. So there's actually 2 ways to produce Qi. One is to mine it, miners are basically given the option when they're mining. They can produce Quai or they can produce Qi. Like so, for any given block, they get to choose. Now, why would they choose Qi? The reason they would choose Qi is because the market price is above their production cost, which means they're going to increase the supply, sell for profit at market, and they're going to keep doing that until the market price converges to their production cost, right? At which point they may not mine any more Qi because we don't need any more Qi right now. But then the other mechanism in the system is you can mint Qi by burning Quai, or you can mint Quai by burning Qi. And there's a protocol offered rate, but basically the previous sort of choices about both mining as well as conversion cause the system to adjust that protocol offered rate until the market becomes neutral to the offer. So that's really just a fancy way of saying that we're using an internal market to self-oracleize the external relative pricing in a decentralized way. So basically at the prevalent market rate, you can move Quai and Qi across. And when you do that, you can much more elastically increase or decrease the supply of Qi, which should cause a much faster convergence of the market price of Qi to its production cost. So it not only then is like an energy-based unit, but it's an energy-based unit that has a highly elastic supply.
Okay, this is interesting. This is kind of, it's kind of like this gold-backed dollar, almost. It's Quai-backed Qi currency in some sense. Like there's some
the problem with the gold-backed dollar, though, is you're still trusting somebody. Like that's
right.
Fundamentally the problem, right? If I have a gold-backed dollar, we're actually just winding the clock back like 100 years. And then the person that's the custodian is going to realize the people that have the gold notes don't always come back all at once to redeem, so they can print a few extra and no one's going to be the wiser.
I know, right? Totally. Yeah. Who knows? Fort Knox doesn't even have gold anymore. It's filled with like Labubus and Dubai chocolate or something.
Right.
Yeah. Okay, this is cool. Now, I know there's been some development recently with this SOAP protocol or something like that. So I kind of have like a mental picture now of like, so there's a kind of a constant exchange rate between hashes and Qi, and there's mechanisms to keep that like converging to the market price. Like basically it's profit incentive to mine more and then sell it right away. And then you have another kind of feedback loop between Quai and Qi that gives like another, I guess, degree of freedom to ensure this sort of
elasticity of supply. Yeah.
Yeah, totally. This elasticity of supply. Now, what is this this SOAP thing that is? I think it's been a more recent development in blockchain world that I would love for you to explain.
Yeah, here, let me bump over this screen I'm sharing. We have a cool dashboard. But the interesting thing about SOAP is here we can look at that. But the interesting thing about SOAP is what is SOAP, first off? It's the Subsidy Open Market Acquisition Protocol. So the basis of SOAP is something called merge mining. So when you're basically mining a block, you can potentially mine another block. So this idea goes back almost 13 years to Bitcoin and Namecoin. Namecoin was sort of the first project to implement merge mining. But basically, they would have a commitment in a Bitcoin header. Bitcoin doesn't like know anything about the Namecoin commitment, but that data that Namecoin inserts into the Bitcoin header allows them to use the Bitcoin header as effectively their header when that Bitcoin header gets worked, right? So it's kind of a way to reuse instantaneously proof of work, if that makes sense. So you're sort of creating co-commitments. So we actually use this quite a bit within Quai already, because that hierarchy of merge mine chains is just co-committing to 3 different chains at once. And then depending on the difficulty you achieve, you'll either get a zone block, a zone region block, or a zone region and prime block, right? So we use it very heavily in the system already. But what SOAP does is it takes it one level further and it says we can actually put our chain into Bitcoin Cash or Dogecoin or Litecoin, etc. So we're actually mining Quai, but then we're also simultaneously mining these other chains. Now, the reason for it is when you have a proof of work consensus system, initially, it's very expensive because the miners are getting paid to mine. And a lot of that money then has to go to market and they have to sell it to cover their mining costs. So unless you have, new entrants into the system buying in greater quantity than the miners are selling, you have very negative like price dynamics, right? But what SOAP does is it says, we believe that the hash rate of Bitcoin and Dogecoin and Litecoin, et cetera, are all underutilized hash. So what we can do is we can use our blockchain and basically co-commit to their blockchain. So we functionally become a mining pool in their blockchain. But the revenue we get from their chain can then go to supporting our chain. So instead of, allowing the miners to merge mine 2 tokens, we just give them Quai, and then the second token, your Dogecoin, Litecoin, et cetera, gets sold at market and then is used to buy and burn Quai. So basically it removes the cost of securing our system and puts that burden onto these other systems, which we believe are not fully utilizing their hash rate, so to speak. Well, what that means is instead of having sell pressure every day, worst case, you're neutral. So the amount of Quai you emit should be roughly equal to the amount of revenue you're bringing in from merge mining these other chains. And then in a price rising environment, you're actually going to be making more money than you're giving out every day. So you actually get this positive sort of deflationary loop where, hash rate gets subsidy tokens buys and burns Quai, which increases the price, which leads to more hash rate, which leads to more subsidy. So you get, it's basically taking a feedback system that had a negative coefficient and making it a positive coefficient. So now your feedback's positive, so the system wants to tend to grow rather than shrink.
Okay, this is very interesting. What do you mean by underutilized hash rate? Like, what does that mean?
So the physics of coming to consensus are constrained by like wires, bandwidth, ping times, compute, etc. And what we've done with Quai is said, what is the maximal like rate at which we can operate within those constraints to get to consensus so that we can maximize the utility for the user, right? And anything that's below that physical constraint is underutilized, right? So we know that we can kind of get consensus in 5 seconds. We know that we can do, say, 800 TPS per shard. We know that we can have many shards, right? Bitcoin, on the other hand, has one block every 10 minutes, and they can do 5 TPS over that 10-minute period. So they have a ton of hash rate, but what they're doing with that hash rate is a lot less than they could be doing with that hash rate, given the aggregate constraints developed by the internet systems, right? So basically, because we're so much faster than them, we can actually function as their pool. So Quai Network is effectively like a mining pool from Bitcoin's perspective.
Interesting. Okay, so kind of like,
but because we can function as a mining pool, we can use that co-commitment to create value for ourselves.
Okay, so underutilized hash rate really means the amount of compute going into this system versus the discrete steps at which that tree is evolving. You could fit tons of more of your protocol within that, like within that time span, within that block rate or whatever. And what you end up doing is people that, I guess, pragmatically speaking, they would subscribe to this protocol on your platform in some way. They will be part of a mining pool that gets that side token, whether it's Dogecoin or something else, whatever that has a lower hash rate than you guys. When they produce that, it's automatically sold at market, and that is then used, that cash output is used to purchase Quai or Chi or whatever, burn it, take it off the market, and that miner is now rewarded with your own currency.
They're still rewarded with Quai. It's just why we give them Quai, we're also buying the same amount of Quai out of market and burning it. So then the net like emissions of Quai should be 0 on any given day.
And that actually increases the value of the thing they're mining by increasing the demand for it.
Correct. So,
cool.
so the real like implication here is that previously, the sort of operational cost of these systems was borne on the system itself. So it was very hard for new entrants to come in because they didn't have as much hash rate and didn't have as much capital. But now with SOAP, what you're saying is any inefficient system or capital that exists is actually the bootstrap for any new network that can come in and increase the aggregate utility of the system.
Interesting. Does this, I'm curious if this would lead to like increased like price correlations across otherwise unrelated tokens, and you'd get like an increase in market volatility this way? Because like now, I mean, this probably happens anyway, just because it's a general sentiment thing. But now, suppose like there's lots of this like this SOAP protocol going on, and then for some reason Dogecoin price crashes, and so the burn rate like on the Quai that is purchased and burned using whatever revenue was from that drops as well. So the additional induced demand for Quai also drops.
Yeah. So it the system is designed to want to tend towards equilibrium. So in step change shocks, you won't necessarily have perfectly equivalent flows, but over time, right, they do want to converge, right? So if there's a shock to Dogecoin or there's a shock to Quai, vice versa, you're still going to see the amount of hash rate want to converge to be like the same value, which then means the flow is still neutral. Now, yes, in any dynamic setting, you're never in equilibrium, but you're always tending towards equilibrium. So I don't think that you'd see an increase in volatility against the relative assets. What you're ultimately going for in some ways is the game that we're trying to play is to get all the hash rate in the world. Like whatever hash rate exists, we want it on Quai, right? Because the majority of the hash rate is grossly inefficient, and we think we can add a significantly greater utility than what they're doing. There's also a step here where we believe we can design a trustless system that will allow the tokens to flow cross-chain, meaning you could take your Bitcoin, wrap it into Quai. That Bitcoin will then have all of the characteristics of Quai network. So, if we are successful, not only should we grow to Bitcoin's hash rate, but Bitcoin may only exist as an asset which circulates on the Quai network.
It's kind of like I just keep converting to like a currency analogy, which is like kind of this like the international dollar or whatever, right? It's kind of like it's if you have like the biggest well, in this sense, it's like if you have the algorithmically best performant network, then you become the default unit of exchange, even when transacting normally in other things, because you can represent them reliably as denominated in Quai or Chi or something.
Yeah, it's kind of like the dollar, right?
Yeah. But not central bank controlled.
Correct. Correct. So that's the other one, which is as like the Chi market matures, we'd like to be able to export Chi. And the whole reason that the US like has this sort of position of power and wealth is because it's been exporting the dollar. That's been our greatest export since Bretton Woods.
Yeah.
Right. That's what creates the hegemonic power and quality of life that we get in the United States. But we believe that the convergence of stable-like tokens only can happen in a work-based setting where the token is related to energy. You're actually seeing with stable coins a divergence, right? You're not getting everyone going to one token. You're actually getting an explosion of different tokens and everyone trying to compete, which is going to lead to a fracturing of liquidity and actually a worse user experience as you try to navigate the 50 different, US denominated tokens that exist. But the interesting thing with proof of work, as well as energy-based tokens, is the market would want to equilibrate to just one or two systems, not many systems. So the dynamic is actually consolidating, not diversifying. So we kind of see this as very positive in many ways, both in terms of obviously scaling the system, but there's only so many replications of proof of work systems that can exist. You can't have like infinite replicates, and the market want infinite replicates. But with stable tokens on proof of stake or proof of authority systems, you could literally have an infinite number of replicates, and the system wouldn't know how to discriminate or consolidate amongst them.
I'm curious then from you guys, like what is the competition then here? Like, are other people pursuing other energy-based proof of work systems? Is there like, I'm curious, like what is the, if there's a convergence on this as like the optimal competitive form, is there still ways of competing, or is it kind of just whoever has the biggest like hash rate lead start, I guess, wins?
Well, no, so what we're saying with SOAP is that the lead becomes less important.
Okay.
Because if you incorporate SOAP into the system, if you can tell a better story and ultimately add greater utility, you can supplant the incumbent, right? So only to the point that there's no more efficiency in the consensus space using proof of work does it become anti-competitive. Now, I would say though, the point at which we have developed Quai is such that we have heuristically approached optimality of what can be done in the consensus space using proof of work. So, if there is going to be a competitor, they would have to start soon.
Right. Yeah.
If that makes sense, because once the network effect does start to take place, and then what ends up happening is, unless you can sort of exploit like a significantly higher degree of utility, you're not going to be able to overcome the network effect. So I guess my statement or my hope would be that with Quai, we've gotten close enough to the efficient frontier that there isn't room for new entrants. But if we're wrong, there will be a new entrant and they'll get closer to the efficient frontier.
Yeah, right. So it's really now, I mean, that's kind of awesome because it's basically saying it's like, it is now just a competition of algorithms, and they're competing on utility and metrics of what we think of as sound currency in this sense. And it's sort of like, I mean, I think this is why it's so cool. It's like the incentives will now optimize for that outcome, regardless of some like political outside influencer actor. And I guess if you get sufficient volume such that there's no one actor who can actually like tip the scales just through their transactions or price action, whatever, then it truly is decentralized. It's really like I'm sure even now, like if someone had Satoshi's wallet and they started selling everything, it would cause a massive influence. Like the whale influence on prices is still significant. But I guess with this, it's like sort of, you can get to the point where no one actor is big enough to actually distort the price signals represented by what is happening here.
Well, that's also one more of the subtle like aspects of SOAP, which is this provides a much more aggressive diffusion mechanism than native proof of work. So if you do proof of work without SOAP, basically you're using distribution, and part of that distribution is forcing coins to change hands between miners and buyers. But the level that you can sustain relative to your total supply is somewhat low because you're also then paying for that security directly every day, right? So that means that, you know, it's a distribution mechanism and it's a diffusion mechanism. What you're saying with Quai right now with SOAP on it, you don't need proof of work to be the distribution mechanism. It can be the diffusion mechanism. But since we've decoupled it from having to pay it out directly, we're using the subsidies to subsidize it. We can actually have, you know, orders of magnitude more diffusion than you can have in a regular system. So if you have this more diffusive characteristic as the system is growing, you're going to arrive at a much better Gini coefficient than you could in any other proof of work mine system.
Gini coefficient in proof of work mining system, is Gini coefficient what I normally think of as this, like all the money owned by one person is a coefficient of 1?
Correct. Yeah. So like if we look at Bitcoin, I think the top 10,000 addresses like hold half the Bitcoin or something.
Right.
So it has a relatively poor Gini coefficient. And if you look at proof of work systems, they tend to follow the same curve, but it has to do with the characteristic that they are using mining simultaneously as distribution as well as diffusion. But with SOAP, you can do it just diffusively, which allows us to have a lot more relative to total supply.
So help me understand this, just because I'm not like a super crypto guy. Are you saying this distribution, this difference between distribution and diffusion is a difference between like mining additional blocks as well as like the actual transactions that can spread these between actors?
Yeah, let me give like an analogy. Let's say I have a beaker of clear water, and I have dye. I have blue dyed water, right? And so I'm pouring my blue dye water into my beaker. That is proof of work mining. So what ends up happening is you have the beaker, you start at a level, you start adding blue water, right? It's eventually going to diffuse and it's going to look homogeneous, but you're also increasing the level simultaneously. If that makes sense. What I'm doing with SOAP is I have a stir bar and I don't actually have to like add new water to the system. I'm adding like drops of dye and the stir bar is mixing it up. Right. And so we end up in this similar state where we have a homogeneous system. It's just when we do the homogeneous system with the stir bar, we get a lot more agitation. So it gets there much more quickly and it's better diffused. Right.
And in this sense, this adding the water thing, are you saying basically when you look at all these coins that have been produced and mined, not all of them represent the same amount of computational work?
When I'm talking about adding, I'm really just talking about the fact that you have to increase the supply to get the mixing done.
And what does the mixing correspond to, I guess, in a sense?
Who has the money? Right. So it's the Gini coefficient. So like how well distributed is the money? So the more mixing I have, the better the distribution is.
And that's because, okay.
So SOAP lets us like turn the stir bar on so we can get agitation, we can get mixing of the system without having to increase the total volume.
Just because the transactions themselves are what's recorded in the ledger.
Well, and we're forcing transactions to take place because we're still minting Quai, and then we're getting this other subsidy thing, then we're selling that, and then we're going to market to buy back the Quai. So you're forcing that volume of flow through Quai every day, which is going to increase the diversity of the set.
I get it. Okay, interesting. So you can get you can support lots of new transactions without necessarily increasing the net total supply in currency, because you're using these sidechain coins to burn in real time as it's mined. Yeah.
So then you'll get a much better aggregate distribution of the system rather than being like hyper concentrated amongst a few early participants.
Interesting. Okay, this is very cool. There's a lot of like algorithmic complexity going on here. I'm curious, like, what was your background coming into this? Because it sounds like you have this mix of economics, physics, mathematics.
Yeah. So I got a mechanical engineering degree undergrad, and then I got a doctorate in material science. I started in my Bitcoin journey in 2012. And it was very much just from a libertarian standpoint, but I hadn't really had formal economic training prior to that. But that certainly got me started on a multi-year journey of learning about money and economics. And then once we had Quai formulated in terms of how to scale, right, we did 2 to 3 years of thinking on how to do the economics correctly. And one of my core engineers too is actually an economist. So he has a master in economics. So between, my research and him, we kind of figured these things out. I will say one of the things that's very frustrating with economics as it exists is it's not a real science, right? It's propaganda. And so you kind of have to like foliate what is like something you can hold on to as being real and what is just, a mirage. So that was actually probably the most frustrating part about the journey, was figuring out, like, is there anything real behind this quote unquote economic science? And if so, what parts, right? So there was a lot of reading. I would say most of the stuff that we found useful probably happened prior to the 20th century than in the 20th century. Yeah. And then there's been a couple inspiration branches. I know Steph referred to them earlier, but there's this field of like crypto economics. So like a couple times since the 70s, a physicist or like a mathematician has been like, I want to dip my toe into economics. And then they start developing a concept based off thermodynamics. So there's a few reference points there as well. It's never been fully developed, never been accepted by, the quote unquote economic community. Yeah, we just kind of had to build it from the ground up, I guess.
Yeah, that's super interesting. Well, there's always been this transfer of physicists into economics, and I think there was this big thing that happened at the end of the Cold War. It's kind of a historical anecdote, but like end of the Cold War, a bunch of physicists ended up going to Wall Street and developing a lot of these like modern high frequency trading models and that kind of stuff, just because they were like physics is the best sort of like competitive mathematics, sort of creative mathematical system modeling kind of mindset. So I just remember this from forums back in the day, but like there's some correspondences between like, I don't know, neutron star implosions and stuff like that, and like kind of esoteric financial modeling. I mean, the Black-Scholes equation is one such thing, which is like the perfect options pricing model based on this kind of turbulent flow type thing.
I think the reason physicists are good at it is just because, they're trying to look at the behavior of a system and model it, right? Totally. And the system can be completely arbitrary, but like once you have that skill set, you can begin to apply it really anywhere that you can measure something, right?
Well, that is this interesting thing in economics, is this concept of performativity, where the model becomes true because people believe it is true, And so now it's like, whether the Black-Scholes equation for options pricing is the perfect risk-free whatever, so long as everyone thinks that's true, the price action will eliminate any deviations from that model for what the price should be of this asset. So I think that's probably where you think it's like the risk of this propaganda. Like if everyone just believes Beanie Babies are this amazing store of value, but the reality can only, like the psychology can become detached from physical reality for only so long, and then there'll be this very rude awakening where
so the interesting thing about it though is the concept of an energy dollar does not eliminate subjective price premiums. All it basically is saying is that competitive commodity goods should approach the price of production, and in doing so, they will be roughly well represented by, this energy token chi at any given point in time, right? So that leaves vast amount of space for non-competitive goods and your expression of subjective price preferencing. But the important part is that it doesn't pollute the money itself.
Totally.
So just because you think a Beanie Baby is like worth a lot doesn't have any impact on my ability to buy my Spindrift, right?
Yes.
Because the money is independent of your Beanie Baby.
And I think more to the point, it eliminates the opportunity for some kind of centralized actor to basically like do things that benefit themselves at the expense of everyone else, right? That, like you said, pollute the money supply or destroy the price signal, or just basically.
Well, so take an example of Beanie Babies, the housing crisis in 2008. That was a Beanie Baby situation, right? we were vastly overbuilding and overpricing homes and allowing people to take debts that had no, purpose or ability to have those debts because the risk was not measured correctly. That's a tragedy of a debt-based money system, right? Versus an asset-based money system. So your speculation on Beanie Babies or the housing price materially impacted my purchasing power because of how it had to resolve through preventing the systematic unwinding of those debts, causing a massive collapse by injecting massive amounts of newly printed money, right? But if we live in a world where the base unit isn't a debt, but an asset, that's much, much harder to do, because as long as I sit in the asset, I'm never exposed to the debt.
Oh, wow. That's a deep insight. I mean, what you're getting really at is that this fractional reserve banking is based on debt. It is based on IOUs. And so it's if everyone wants to clear their debts at once, it's impossible. And that is the liquidity crunch. And that was like the same with the Silicon Valley, so like SVB banking crisis a few years ago as well, which was like they were exposed to treasury risk. And so I think treasury rates went up too fast or something.
Yep.
And then
they were underwater.
They were underwater on this. So basically this debt-based fractional reserve banking system, you cannot clear all IOUs at once. But if it's asset-based, is it guaranteed that can't happen, or is it just less likely?
So what would happen is some people will decide that they want to have debts because there's like a reason to have debts in the economy, but it isn't the baseline and it isn't like done for you. So to sort of pull this thread a little bit more, if you're sitting in a field with $100 bill and you're like, I got my $100 bill here, no one can influence my $100 bill. That's not true, because that $100 bill is a socialized representation of all of the bank's debts, the private bank's debts. So like the underwriting at JP Morgan for their home loans goes into the value of that dollar that you're holding physically, because they're the ones that are able to increase and decrease the supply, right? We say it's the central bank, which also is a consortium of the private banks, just so we're clear. But in reality, the 95% of the money isn't issued by the Fed, it's issued by the banks.
Right.
Through creating new debts. So it's so pernicious in the system, there's no way to have a dollar that isn't a debt. All dollars are debts, right? But let's say I have chi, right? Now it's like I have an ounce of gold or I have a note for an ounce of gold. Now I know the difference. So if I have chi and I'm just like, I have chi, I'm not in this, debt-based note market. I know I'm not in this debt-based note market. That's not the default entry point for using the money. You can be in the asset-based money, and if you want to get yield, you can decide to get yield by creating a loan and then creating some derivative representation or promissory note against that loan, but it will clearly be different than the asset.
Right.
Which means you're going to be much more diligent about who you're loaning, what how much you're loaning, and what your risk payback needs to be directly to the asset holder, rather than having this confused socialized system where the government is sort of this like originator of all debts through the government bonds, the Fed's the originator of all the money, and then the banks just always are the ones taking the skim in between of the interest, right? When I put $100 in the bank, they'll give me maybe like 30 bips and they'll be making like 5.5 points, right? It's because we live in this weird conglomeration of debt-based money and there's no hard asset. But if we started to say, let's reimagine the system as if everything was gold, tokens, and like I knew I had a token or I had a promise to a token, I would know the difference between those two things.
Mm-hmm. Yeah, this is disconcerting, realizing that there's no floor, but it's just debt all the way down, and you know, it's like completely illusory. I'm curious though.
You know what happened with SVB? Most people don't know this. So what the banks did to prevent, or the government did, the Fed did, to prevent the systemic collapse of the regional banks, because you had Silvergate, then you had SVB, and then there were like a couple that were coming after it. To stop that, you know what they did? They allowed all of the banks to deposit their bonds with the Fed and get full face instantaneously. So you basically went from like a 10% reserve situation to a 0% reserve situation. So since that point in time in 23, we've effectively lived in a 0% reserve fractional banking system.
Oh, wow. That seems like really bad.
Yeah. That's where we are though. Since SVB went under, there's no reserve requirement, because I can literally take my bond, which has yield, has interest, has like a current base and par, and I can just give it to the central bank and it'll be like, here's, you know, a full 100 cents on the dollar.
Help me understand this. I'm going to keep asking because there's something in this whole the Federal Reserve central banking. I've tried to learn it like a dozen times and somehow it doesn't stick. I think maybe because it's deep, it's fundamentally hallucinatory in some sense. So it's just like I can't. I'm looking for this like self-consistent mental model and it's not there. What do you mean when okay? So let's go back to SVB banking crisis. They had what caused that crisis? I just remember it was the increase in interest rates beyond what people had forecast. And so what does that mean?
So basically what happened is
bonds that have a fixed yield rate, but now the current interest rate goes above those, that the relative value of those bonds now goes down.
The liquidation value of those bonds. So if you hold them to maturity, you'll still get the full value of the bond, but the instantaneous value is below $1. Right. So when it went from 2.2% up to 5.5%, they had been buying all this long maturity debt at 2.2. So now if people came and they said like, we actually want to collect on our dollars, they only had bonds and the bonds were worth less now. So they actually had a gap in, their book, right? They were underwater.
Yeah.
Right. So then the Fed stepped in and basically said, give us all your government debt and we'll give you the full value of the bond for it right now so that the system doesn't collapse.
And so basically, is that now the shortfall in this book value was just adopted by the Federal Reserve?
Yes.
Okay. And because they don't have to be solvent or something.
They're the origin of the money.
Yeah. So basically that money was just created and given to banks.
Yeah.
And so so the banks just like were too important to fail. And I mean, actually, I would say, like in hindsight, it's I think the Federal Reserve was giving guidance that they were not going to be increasing the rates, and then they basically rug pulled everyone by increasing the rates super fast. And so this was like sort of this, like, it's I don't know how much fault lies with where. I mean, the system itself sounds like it's fundamentally nonsensical, but.
So one of the things in the design of Quai that, and this is just blockchains for you too, is I would say a blockchain technically is not technically a technical system. It's actually just a definition of markets. And there's only like a couple things that bind the markets to a technicality, so to speak, which is like your hash function, your sort of emissions policy. But a properly designed blockchain is just creating a series of markets. So the reason we did that is because we don't have the hubris to say that we can predetermine what should or shouldn't be. All we know is that efficient clearing of markets is good design because the collective intelligence operates on them, right? And so the problem that you see with the Fed isn't the Fed itself, because you're giving them an impossible situation to actively control an economy, right? But if it was a market and the market had a fair way to discover the rates and that resolved like correctly, because say you had hard money instead of like Fugazi money, right? Then the collective intelligence of the market would find equilibrium. But basically, we've then put this intermediary that has the power to create money, and then we're also telling them to manage the market using that power, which is like the flaw, right? So you don't get the collective intelligence, you're never going to get it right, no matter how smart you are.
Yeah, I think that's really good framing, and I think that is the power of markets, is this intelligent superorganism that emerges via all of our individual decision making, and you can't really, I mean, I don't know, maybe like a ASI, Federal Reserve, would work or something like that. But I think that's actually, I mean, this is another thing, you know, Elon, our space king in low orbit heaven, said recently, was that you know, you could maybe get ASI through like a bunch of interacting AI agents or something like that. Like, and I think that's maybe, you know, because I think like the market and the economy is a super intelligence. It is solving a coordination problem that no one person can solve on their own. It is smarter than any human by far. Like in its.
Yeah, I think the statement would be true. You'd have to have enough diversity of the agents and their information sources.
Right.
But if because that's where it comes from, right? Like if we look at the resilience of that collective intelligence, it's diversity, in both like you know, relative subjective pricing, you know, future expected values, information asymmetries, right? You would need that level of diversity to get it from like an artificial system. But given that, I mean, let's be honest, we're similar, right? We're the wet version of it, but like we're more and more analogous. You know, I don't think they're quite there yet. I don't think that the way that we do generalized networks, right? I think that if you look at the brain structure, that evolved for very good reasons, and the fact that we sub-optimized certain parts of it, or optimize certain parts to do very specific processing. So that's like an optimized neural net for spatial awareness, an optimized one for language, an optimized one for vision, an optimized one for this and that. And then we put a meta web over it. You know, I think that there's something to be said for that. And I haven't seen somebody do that in the AI space. But you know, but the point is they're getting sufficiently complex that you can get very stochastic emergent behaviors. You just have to, again, have great enough diversity of those things, and yeah, you'll get the same outcome.
I'm curious what you think, and I mean, this could be our last tangent, just because like you have to come back more. We can just keep riffing on stuff. I've had this view. You can maybe say it's wrong or right. I don't know, but that. You know, cryptocurrencies and blockchain technology, it seems like that will naturally be the market on which AI agents, or, you know, artificial intelligence, if we give them purchasing power and that kind of stuff, it sounds like they natively have to transact on those formats. Or, oh, what's this? Is this?
Oh, I just put it back to live here.
Yeah. Okay, cool. Have you guys thought about that at all in this kind of like, and this is kind of like the Charles Stross, like Accelerando sci-fi, where you know, economic agents now, if they're AIs, and I mean already there's like trading models that do this, but more generally, if they're like involved with running a company and making purchasing decisions, and I know Amazon does this internally, is like it's you know, where they source things and all this kind of stuff. It's automated in some sense. Have you guys explored this intersection? I guess like AI agents, robotics, blockchain.
Yeah, well, so what I think is the most interesting is the reward function in society. So right now we have political money, and the reward function in society does not optimize for aggregate well-being and wealth, because we have political money. It offers people outside rewards that can use politics to manipulate things in their favor, to potentially blackmail and bribe people. So you get this, you know, sort of kleptocratic, you know, self-reinforcing bureaucratic system of. Still haven't seen the Epstein files. That's all I'm saying there.
Yeah, totally. Yeah.
But like those are outcomes of political money, is that you get political outcomes. You don't get outcomes that increase the aggregate wealth. If you reframe that money to be energy based, and then goods and services are all pricing in this energy, right? Then going back to that graph you mentioned, right? Energy is sort of the best metric for correlating a well-developed, prosperous society, right? So if I can make my reward function tightly tied to energy, i.e. human well-being, we'll actually get way better societal structures and outcomes, because the political ones will no longer work. And so if I were to try to extend this analogy to AI and say, how do we make AI safe, and the outcomes of AI benefit us rather than something else happening, it would be aligning the reward function of the AI with the well-being of the humans, which is energy-based money. So I actually think of all the systems that we could come up with to put guardrails on AI, it's really just reformulating the reward function in such a way that it's so tightly integrated to the physics of human well-being and can't be manipulated, that it causes all AIs to work in a benevolent way towards the betterment of human well-being.
Mm-hmm. That's very interesting. I think I would like broadly subscribe to that view. I think with the additional caveat that it's like the AIs themselves are truth seeking. They're truly empiricist. We are not biasing again, but it's kind of like a political thing. Like we're not biasing them into believing things that are convenient or nice or feel good or something like that when they are not true or something like that.
But I don't need to know their motivation. I just need to know what they're motivated towards, and that's aligned with like human interest.
Right. Which is, I mean, and that's where we started. It's the abundance, availability of free energy, right? Our ability to acquire, produce, consume this energy. And so I don't know. I mean, I think I'd close with this. It's like, we got to be Kardashev scaling, we got to be Kardashev maxers, right? And so having a energy-based currency seems like an inevitable component of that, the future economy.
Yeah, I would add on to that and say that I don't think we've ever actually had capitalism.
Oh, it's a hot take.
I think the structures which we have called capitalism has some characteristics of it, but we've never had pure capitalism. So I think it will be interesting if you can vastly increase the efficiency of the information system, the money, and redirect the reward function away from politics to truly increasing well-being. I think that could be like the biggest step we've had, and like that's like an epoch of mankind right there, because those efficiencies are going to compound every day, right? And sometimes we like lose sight of that. I'll give you two examples of sort of compounding efficiencies. If you had $1 and you managed to double that dollar every year for 20 years, you'd have $1 million. If I took 25% tax on that every year, what do you have at the end of 20 years?
I don't know.
65,000.
Damn, dude.
Yeah.
Brutal.
So the 25% tax actually steals 94% of your wealth.
Ugh.
Yeah.
I think this is now especially relevant with like kind of uncovering this, like the extent of government fraudulent spending and wanting to tax things more, right? I think it's indefensible, but
the thing is, there's no pushback on it. There's no tie, there's no grounding, because the system is arbitrary, the system is fictitious. They can just take the money from us, right? And they can just print more. They can either directly take it, or they can just print more of it and take it. So they can tax us on savings and on earnings, right? And in a system like that, there's no accountability, so you end up with the Somali daycares, right?
Yeah.
But if the system is self-sovereign, meaning I can actually own my money as an asset independent of a bank, and that money can't be manipulated, we can still have social systems. You just are going to have to justify what you're doing, and rational people will participate.
And that's probably like the biggest barrier to adoption here, is the fact that it makes this corruption, grift, fraud, theft, abuse impossible. And that has become so baked into like the state of affairs, the revolving door between industry, policy, and government, and all this kind of stuff, that it's so brutal, but it's true that like the extent to which this fraud can persist is really measurable by the extent to which the public can be deluded as to their own self-interest and manipulated by usually emotional narratives to whip them up into a certain belief system. And it's like, this is like the feel-good fund for XYZ, and then the money's actually used for just like, I don't know, whatever, like, political lobbying or buying a second house in Vermont or whatever.
Well,
right?
Look at all the senators. They all are worth tens of millions of dollars.
Exactly. Yeah, exactly. Yeah.
Right. But
yeah.
with the, interesting thing there is that you kind of start to go full circle on like, fix the money, fix the world. So why is it that Bitcoin isn't good enough? It's not good enough because people can't hold it themselves and use it every day. Right? If I can get it so that a mom is buying her groceries with it and filling up her van with gas with it, that creates a degree of social resilience. And that creates, it also just removes the economic power, right? So if suddenly everyone started using Qi, the dollar would be worthless, right? If the dollar's worthless, then you can't hold up this house of, graft and corruption.
Mm-hmm.
Right. So fundamentally, like, it's so pernicious, say, what you will of Donald Trump, like he went there trying to like slice it up, right? Trying to remove waste and efficiency with the help of Elon. But even with, that much aggressive action, there's a very limited effect that you can have on such a large system. Mm-hmm. Right. The only way that you can reset it is by resetting the base, which is the money. So the money that we're designing has to be adopted from a grassroots perspective by people because it's in their own best interest to do so. That means it has to be easy enough to use, cheap enough to use, and show clear enough benefit that you just start using it because it's better. And once you get to that point, then you actually have fixed the money, which will allow you to fix the world.
Damn, dude. Well, then what is your call to action here? Like what can people do, or what are you guys looking for also? Like, are you guys hiring? Are you looking for new collaborations? Is there like easy ways for people to get involved or adopt it? Is it like we need more stores that would accept this as a currency, or is there some kind of like adoption rollout plan? Like, how do we get people to using this?
Yeah, I mean, it's all of the above, right? So we spent a lot of time like figuring this problem out before we went live. So the genesis of the idea of Quai actually happened in 2018. And it was a research project for a while, National Science Foundation funded. And then in 22, the beginning, we got funding to kind of do it full time. But we spent another 3 years getting it to the point that it like worked before we went live. So we didn't sort of ship something and then spend a decade trying to fix it. We shipped the thing that we think we can scale. So that being said, we're still in the first year of this thing actually being live. But people coming to work for Quai, right? Buying Quai is obviously helpful, helping us get better accessibility to Quai. So if there's a wallet that we can get integrated to, or an exchange that you could help get a listing on, those are all helpful things. And there's also, building of applications and whatnot on the system. One of the things that's really cool about Quai is because it's so fast and so cheap, you can actually build an application and you can scale the application. In many situations we see with blockchain, you get sort of a product market fit of a, Uniswap as an AMM, or you get, a CryptoKitty NFT, and it starts to sort of take off. But because the chain itself can't scale, it sort of kills a lot of these ideas in their crib, because the idea can scale, the use case can scale, but the chain can't. So one thing that's cool about Quai, because we spent all of this time making sure that it can scale, is that if you actually build something on it that's useful, the chain will scale with you, which isn't something anyone's ever really been able to say. So there's a lot of cool applications that, take advantage of this and kind of make it so that Web3 looks very much like Web2, and we're not doing it in a centralized way. We're not doing it with, proof of authority or some sort of L2. It's all happening on the main chain, and it feels very much like a normal web-based experience.
This is awesome, man. I think this is awesome. And I'll just reiterate, I've never been like a crypto guy. I've never been like into stuff. And I kind of came to this point of energy-based currency as like the natural like solution of like aligning incentives at the broad scale and more just for like business development, economic growth. It has this massive part you talked about, which is this like political theft, fraud, abuse that can occur because it's ultimately political money. And then even that, it's debt-based money, and so there's the systemic instabilities are rampant. But there's all this like just cool stuff. Like it's the causally invariant hypergraph computation. It has like these correspondences to fundamental physics. So I think what you're working on it's really cool. It's really cool. I don't know. I maybe I should probably buy some Quai or something at some point. I don't know. I'm never like a speculative investor, but
yeah, I mean, from my perspective, right? I got into Bitcoin early, so I don't like have to be here, so to speak.
Yeah.
But there's like two roads that we're kind of going down as a society. We maintain our digital world, and that advances. We have one road which looks like a CBDC, a la USDC or USDT.
Sure, what is
going to, create a panopticon that is going to be very pernicious for human freedom. And then the other road that we can go down. Sorry, 1 second. 开开，关掉了。谢谢。The other road we can go down is one where we actually realize sort of the dream of Satoshi, which was P2P electronic cash, and we create a money system that is truly independent, truly decentralized, truly uncontrollable. And then we've built the tool that potentially will create, this blossoming of human freedom and creativity in a digital world. But if we don't realize that, we're going to get ourselves into a situation that I think is like incredibly bad for an incredibly long period of time. So like the reason that I'm building Quai is because no one else was building that second system. And this is like my best effort at doing that.
That's awesome, man. That's awesome. Thank you so much for your time. I really appreciate you being here. And hey, we got 2,200 people watching live. So where can people find you guys? Where can they follow along as the last thing?
Yeah, you can check out our website at qu.ai. You can follow me on Twitter. Handles Mechanical K, spelled Kalk at the end. You can also follow the Quai Network account. We also have an active Discord. So if you're a developer, want to build some apps, want some direction, drop in our Discord and we can help you out. If you want to mine, right, with SOAP or 3 algo mining now, you can mine with a GPU, a script ASIC, or a SHA ASIC. So you can contribute that hash rate. Yeah, lots to contribute. So.
And come out to Austin Deep Tech Week, right? We're going to do, I think, end of April. So I'll stay tuned on more to come. But thanks again for your time, man. Really appreciate it.
Yeah, appreciate it, Andrew.
Okay, cool. All right. Take care. All right. That was energy-based currency. That was an awesome conversation that touched on a lot of stuff. And I think it's ultimately correct. I think basically our ability to navigate the complicated trade-off space of economic decisions depends on having accurate and reliable price signals. And this is, information is not evenly distributed throughout the world. Everybody has their own local view of things, and we're trying to piece together this stuff. And because of the asymmetry of information distribution, the market will always outcompete any kind of centralized authority, centralized decision maker. And more to the point, I think the reality we can now face is that there's just so much fraud and abuse and the ability of governments to print money on demand whenever they like is a massive source of inflation. And inflation is the destroyer of all wealth. Ultimately, it is the road to serfdom. And that is an unfortunate fact. But fortunately, we live in an era where technology and science are continuing to advance at an absolutely absurd pace. And so I think we can kind of build our way out of this. I think we can engineer enough civilizational abundance so that we avoid any kind of catastrophic outcome. And really it's a matter of how do we adapt our social and political systems fast enough to take advantage of these new technologies, to take advantage of our understanding of science and mathematics and system level design to get out of our own way. And I think you see that today. I think, the biggest impediment to progress is no longer what's been discovered in a scientific laboratory, but it is the regulatory framework we have, which can adopt a rapid pace of change in the physical environment. And the history of software development has been basically blue ocean, unregulated markets. And now we must turn our attention to the difficult task of uprooting, long-standing market incumbents in physical industries and things like unionized shipping terminals and kind of stuff, saying we're never going to have robotics here. I mean, this is obviously it is to the detriment of everyone, to the benefit of the very few. And I think that is a good tagline to understand, central banking and fiat currency as they're constituted today. So energy-based currency, I think, is a pretty good idea. I think Quai network, again, I'm not, not paying me to say this. I'm not buying a bunch of their currency or whatever, but something like this is inevitable and necessary. We need to fundamentally decentralize this market information. We need to get it outside of a centralized authority, and we need to ultimately align our economic activities with the thermodynamics of industrial civilization. We cannot get around this requirement that we must acquire and use free energy. And so we can't afford to paint ourselves into a corner. So thanks for joining Hyperstition number 11, energy-based currency. And we'll be back with more cool stuff. Tomorrow, we're going to talk about space guns. We're going to talk about shooting things into orbit with long shot. So that'll be 1 p.m. PST. Until then, stay frosty.